The second part of section 9.1 is continuing our discussion on significance testing or hypothesis testing. In particular, this part of the lesson is going to talk about the types of errors we might have committed when we do our conclusion. All right, so there's two types of errors, type 1 and type 2 errors. When that we might have committed if we draw a conclusion from a significance test. And so we might reject the null hypothesis when it's actually true, in which case we've committed a type 1 error, or we may have failed to reject H naught. Those are the two possible outcomes. Either we reject it or we fail to reject it. But if we fail to reject it when it's false, when the alternative is actually true, then we've committed a type 2 error. Now, these sound like it's something we've done wrong, and it's not. These errors occur because we've done everything correctly. And of course, we're not actually going through any hypothesis tests yet. We're not going through the mechanics of them. We will do that in the next two sections. But when we take a sample and then we analyze the data and we look at the sample statistic, the sample statistic might be extreme. And so that would give us evidence that we should reject the null hypothesis. And in which case, perhaps, maybe that one sample that we took is an extreme sample. And as a result, it's indicating to us that it's very unlikely that the null hypothesis is true. And as a result, we reject it. And it might actually be true. The problem is we don't really know. So this is not something you've done. It's not like, oh, you're going to get points off on a test because you've committed a type 1 error. The type 1 error occurs because the sample data has led us down this path that causes us to conclude the wrong thing. And so it just happens. Sometimes there's nothing you can really do about it. It's not that you've done something wrong. It's that the sample data is not representative of the population. Okay, so this table sort of shows the four possible outcomes when you're doing a conclusion. So the top row is you reject a null hypothesis. So on the top right corner, you have the correct conclusion if H naught is false, right? So if we look, this two-way table sort of says, either H naught is true or H naught is false, and then you either reject it or you fail to reject it, right? And so the correct conclusion up here is if the null hypothesis is false, we hope that the sample will indicate to us that we should reject the null hypothesis, and we've done the correct thing. However, if the sample indicates that we should not reject the null hypothesis, then we've committed a type 1 error. The other two options are that we fail to reject the null hypothesis. So the data is such that it tells us, the statistic, that we should not reject the null hypothesis, that we fail to reject it. And when it is actually the null hypothesis is true, then we've done the correct conclusion. However, if the data is such that it indicates, the statistic tells us that we should reject the null hypothesis, or that we should fail to reject it, but it's actually false, then we've committed a type 2 error. All right, so really there's just four possibilities here, and this is sort of it's sort of restating what I just said. We could reject the null hypothesis when it's false, and that means we've done the correct thing. We might fail to reject the null hypothesis when it's actually true, and we've also done the correct thing then. We could reject the null hypothesis when it is true, and that means we've committed a type 1 error. Or we failed to reject H naught when H naught is false, and we should have, and in which case we've committed a type 2 error. The issue is that this is all theoretical, and we really never know whether we've done the correct thing or not. We don't know if we've committed a type 1 or type 2 error. We'll know, we will know, like, okay, if we reject it, we know like, oh, we might have committed a type 1 error. And if we failed to reject it, we'll know that, oh, we might have committed a type 2 error, but we really never know whether we committed an error or not, whether we made the correct decision or not. We make our decision based on our sample data, but that might just be a non-representative sample, an extreme sample that may not be representative of the population. So we might have committed an error. All right, so in a little way of remembering which type of error, type 1, type 2, which one's which, if you fail to reject H naught, then you might have committed a type 2 error. Now, I mean, those are obviously two different 2s, but it's kind of a good way to remember it. So fail to reject, then you may have committed a type 2 error. Otherwise, it might have been a type 1 error. Okay, so let's think about the type 1 versus type 2 errors here. A type 1 error, the probability of committing a type 1 error is the probability of rejecting H naught when it's actually true. And this is exactly what the significance level is. And so this slide and the next slide endeavor to explain that to you visually and get you to understand that. So the significance level alpha, remember that is if the probability or the p-value is smaller than alpha, we're going to reject the null hypothesis. So this alpha is a probability threshold, right? So if the p-value is smaller than the alpha, so you can think of the alpha as like this probability, but it's a threshold about which if our p-value is smaller than it, then we're going to reject it. So remember, probabilities under the normal curve are represented by the shaded region. So in our curve here on this slide, we might think of that shaded region as representing our alpha. And if our p-value is smaller than that, further down into the tail than that, meaning its shaded region is going to be smaller, then we would reject the null hypothesis. But often, it's a normal curve. Often, not often, but sometimes we're going to have a p-value that's out there, even though the null hypothesis is true. And if our p-value is small enough, our statistic is far enough down into that normal curve, we would reject the null hypothesis when it's actually true. All right, let's try showing this in a slightly, with an example. All right, so here is sort of a graphical representation of what this type 1 error and the relationship between it and the alpha level. So let's start with a null hypothesis. So I don't have any context exactly with this. So let's say the null hypothesis is that the population mean is 8.5. And let's say that our alternative is that the mean, mu, is greater than 8.5. And then mu is just some population mean. Again, I didn't bother with any context for this. So our mean right there in the middle is we say mu sub naught, which represents it sort of represents the mean from the hypothesis. So that's this thing up here. We often put a subscript of naught on that mu to represent the fact that it is coming from the null hypothesis. Okay, so the hypothesized mean value is 8.5. All right, the shaded region is that alpha level, and we've set it at 0.05. So 5% is the alpha level. All right, and so if our X bar is further down into this shaded region, so if our X bar is anywhere to the right of that little threshold value, then we know that we would end up rejecting the null hypothesis, because then our shaded region would be smaller than the shaded region that is represented by that alpha level. Okay, so all right, so using your understanding of the normal curve and assuming that our null hypothesis 8.5 is actually true, how often would we expect sample statistic, or X bars, to be in that shaded region in the top right corner. So we would expect that to happen. How often? And we would expect that to happen 5% of the time. Even with the null hypothesis being true, we have a distribution such that, the X bar might fall in lots of different spots along that number line. And so it will be in that red arrow area 5% of the time. All right, so any X value in that region would be extreme enough for us to say, it's not very likely to happen. It's less than 5% of the time, so we're going to reject the null hypothesis. Well, if we reject the null hypothesis when it's actually true, right, that means we will do that 5% of the time. And so what kind of error is that? If we are rejecting the null hypothesis when it's actually true, we may have been committing a type 1 error. All right, so what is the probability of committing a type 1 error? So we can see that that is really just 5%, or the alpha level. So this whole thing is, this whole slide was about trying to explain to you that the probability of committing a type 1 error, remember, type 1 error is we reject the null hypothesis when it's actually true, is 5%. So 5% of the time, we may have committed a type 1 error, assuming our alpha level is 0.05. Okay, so this is your homework due next class.